Hi everybody, this is Mr. Karlovsky. We're going to step through the notes here to section 10.5, which is on something called partial fraction decomposition. I encourage you to fill out your note sheet as I do it. There will be a couple times where I have you do the problem by yourself, and you'll also see that sometimes I will pause the video. And where I don't have to rewrite everything just to make things go a little bit faster for the video. All right, so let's get started. Partial fraction decomposition sounds very fancy, and basically what we're going to do is the reverse of what we're first going to do here in this example of simplify this rational addition of 2 over x plus 2 plus 3 over x minus 4. We've done this problem before. I'm going to go through it kind of quickly. Obviously, we need a common denominator, and so I would multiply the first fraction by x minus 4 over x minus 4, the second fraction by x plus 2 over x plus 2, get a common denominator, and combine. So if you don't mind, I'm going to kind of fast forward to that real quick. Okay, so that would be my expression. You see I multiplied and combined the two fractions, and now what I'm going to do is simplify the numerator to be 2x minus 8 plus 3x plus 6 all over. And again, I'm not distributing out that denominator. You really don't have to here. And so my final answer at the end would be 5x minus 2 all over my two factors, x plus 2, x minus 4. So we've done that example before, and now what partial fraction decomposition is going to be a way for us to start here with that single rational expression and then decompose it into those two single fractions. That's what this method is all about. As you see on your note sheet, there are 4 cases, so we have a lot to get through. Each case is different, but you'll see some patterns emerging. Okay, so let's try and get through this video as fast as we can. At times, like I said, I will have you work on a problem yourself and then just check the answer. Other times I'll be explaining every single bit of it, okay? So let's get started. Now, if you see, this first example that we're about to do right here for f of x is actually the one we just did. So we already know the answer to this first one. This first one, case 1, it says, so if you come over here, you see that we're talking about taking a single rational expression, p of x over q of x. That could be any rational expression where p and q are polynomials. We're going to break it up into its single fractions. Now, case 1 is when q of x, my denominator, has only non-repeating linear factors. Now, so our first example of 5x minus 2 over x squared minus 2x minus 8, yeah, if I factor that denominator, x minus 4, x plus 2, you see how this qualifies that my denominator has linear factors, right? X minus 4 and x plus 2 are linear, and they're non-repeating. Now, what you'll see in case 2 and 3 and 4 is sometimes the repeating would be like x plus 2 squared, which of course this example does not have. That would be an example of repeating. Okay, and now if you, I know you can't see what I'm pointing at, but over here, again, is that when you have non-repeating linear factors, you're going to break up into, there's going to be a single fraction for each factor. That's the dot, dot, dot. So what are we going to put in the numerator? The good news is for linear factors, what goes in the numerator is just a constant. We tend to use capital letters, so I encourage you to do the same. So a constant will go in the numerator, and then each factor will go in the denominator of each fraction. Okay, so we would plan out for this problem that, okay, since there were 2 linear factors, I am going to set up, and I'm just going to quickly dump that all on the screen. And boom, there it all is. You see how I've set up the problem. I wrote down my original expression on the left, and then I've set up that, okay, I'm going to have 2 single fractions of some constant over x minus 4 plus some other constant over x plus 2. We don't know what those constants are, and that's really what we're going to do, is we're going to find the values of a and b, and that'll be our answer. Notice it does not matter because it's addition. If you want to do the x plus 2 fraction first and then the x minus 4, that clearly does not matter. All right, so now imagine we were solving this equation. What we often would do is clear out our denominators by multiplying both sides by whatever it would take to clear out all of our denominators. So in this example, it's pretty clear that we would multiply the entire equation by x minus 4 and x plus 2, and that would kill all of our denominators. So let me jump to what that next line would look like. Take a moment to look at where I just jumped to. Imagine I just cleared out my denominators. Okay, so now what we're going to do is we're going to figure out, what would a and b have to be for this equation to work all the time? Now this method, again, this is case 1. This method is very, very easy, and everyone will get this right. What you're going to do is you're going to choose to substitute in values for x, not for a and b. We're trying to find a and b. Substitute a value in for x and solve for a and b. It's basically going to be a system of equations. However, in this method, we're going to purposefully pick some very nice values for x, specifically -2 and +4. Why do you think we're going to do that? Because those would make the factors 0, and 0 is a nice thing to work with. So imagine, I'm going to do both of them here. I'll switch to red pen here. Also, if you don't mind, I'm going to erase a little bit just to leave some space for me here. So what I'm going to do is I'm going to substitute in x, it's purple, let's see if I can switch to red, x equals -2. Okay, I'm just going to make a little note to myself. I'm going to substitute in x equals -2. All right, well, that would be 5 times -2 minus 2 equals, and now the reason I picked -2 is because when -2 is plugged into x plus 2, that will be 0, and 0 times a will be 0. So I'm going to not even write that down. The a term will be dead, and we'll be left with b times -2 minus 4. So you see, we now have a single equation to solve for b, and voila, we have now locked in that b equals 2. And hey, b is the constant that's above x plus 2, and looking at what our original problem was, hey, we did it right, that it is supposed to be a 2 above x plus 2. All right, now I'm going to do the exact same method for the other value of 4, the number 4. I'm going to plug in 4 for x and find a, and then we'll be done. All right, so if you don't mind, I'm going to erase my current work that's in red and substitute x equals 4. And if you need to pause to have a look, do that. So you see, if I plugged in 4, I would have 5 times 4 minus 2 equals, and then this time 4 would plug into the a term, but it would kill the b term with a 0. And so we would solve this. And now we have that a equals 3. We already had b equals 2, and now we are done. And your answer, of course, should be the expression where you plug in a and b. So your final answer should be that you have 3 over x minus 4 and 2 over x plus 2. Okay? So now what I'm going to have you do, I'm going to get you set up on the second example. And then you can try it on your own and check your answer in a moment. So for the second example, let me just get you started. First thing, of course, is to factor the denominator. X minus 5, x plus 2. Again, we have 2 linear factors. We now set up the equation. That's my equation. And now, clear out your denominators, plug in values. What are you going to plug in? And then find a and b. Go ahead and pause this video, try it on your own, and then restart the video to check your answer. All right, if you set it up correctly, When you plugged in -2, you should have gotten b equals 2. When you plugged in 5, you should have gotten a equals 4. And so your final answer would be 4 over x minus 5 plus 2 over x plus 2, and that would be your answer. Okay, that is case number 1. All right, that was non-repeating linear factors. That took about 10 minutes. I know the other methods, I'll try and go a little faster because the technique will be very similar. But this is the end of the first video. And now, when you're ready, move on to case number 2.